Eric Burgess here. Given 8,083,000 male citizens and 10,097,000 female citizens, 60.6 of the male citizens got aid and 65.2 of the female citizens got aid. Of those receiving aid, 44.8% of males and 50.4% of females got federal aid. Choose one at random. Find the following probabilities. So this one is quite a doozy. We've got percentages in numbers. The numbers are not nice looking at all. And so let's go ahead and dive right in. So A, male without aid. B, male given aid. And C, female or receives federal aid. Okay, so here we're looking for a male without aid. So there's a couple ways we could go about looking at this problem. I think the first way to go about looking at it is to create a chart, right? So if we were to make a chart, we'd start at a point and branch off. And these branches, right, the first branch, we'll call this the male branch, and we'll call this the female branch. So the chance that someone is a male is going to be everything combined with just the males on top, right? So our sample size, remember the definition of probability is sample size and then the condition on top. So it's everyone and then male on top. So we're going to go ahead and do that first. So I'm going to come in here and I'm going to do 8,083,000 plus 10,970,000. Just make sure I got all this right. Don't want to make a mistake here. 10, 3 zeros, 380. Cool beans. Up here, we're going to put our condition. So, right, this is everyone all together, all the males and all the females added up. And then we're going to divide by the males. 0, 8, 3, 0, 0, 0. So we got 3 zeros, 83, 0, 8. Perfect. So this is going to be the chance that they're male. And we do that, we find that this is 0.4242-ish. All right, so we're going to do the same thing for female. We're going to come up, we're going to just write over this number. It's the exact same thing, only this time it's the female number. So it's 10,970,000. So 10,970,000. Perfect. We enter. And this is 0.5758 when you round. I'm going to 4 places. So when we add these, we should get 1, or a number very, very close to 1 because I rounded. So we're going to have 0.4242 plus 0.5758, and we get 1. Wow, that just is spectacular. Perfect. All right, so that's the first branch. We have male and female. Then after that, we've got male citizens that get aid, which means that there are male citizens that did not get aid. So we've got male citizens that get aid. So we're going to call this aid, and male citizens that did not get aid. I'm not going to write it in. I'm going to leave that space for a number, but this is the not aid category. So for the aid, well, we know 0.4242. Well, this is male. And then if we say male and aid, well, that's going to be male times the chance that they got aid. Well, 60.6% got aid. So we're going to multiply by 60.6. This is like male and aid. Oh, whoops. This is a percentage. So it's going to be 0.606. So that means that 25.257 is what we get for male and aid. And now this is really male given aid. So it's really B that we just calculated, because this is the fact we're assuming they're already male and we're given that they've got aid. So that's 0.257. So we've actually done B here in doing the chart. Now, of course, we're going to do this one down here. So this is going to be 0.4242 times the fact that they are male and they did not get aid. So that's going to be 0.4242 times, and then the people who didn't get aid, well, that's 1 minus the percentage of aid, right? So this is like just saying, well, if 0.606 got aid, then if we take 100% minus 60.6, that's going to leave us with a percentage that didn't get aid. And we get 0.16713. Or we'll just go 1671. So this is saying that this is male, no aid given male is what this is saying. And when we add these, we should get back to this number. Now I rounded, so it might be a little off. We're going to take 0.257 plus 0.1671, and we get 0.4241. So we're barely off. That's just attributed to rounding. So there we go. And that's our first branch. And we're going to do the same thing for the females. I'll go faster for the females. We got one more branch though. And then we say, of those receiving aid. So if we've got given male and aid, well, now we've got given aid and male. Given aid, given male. We've got some more information here. 44.8% of males and 58.4% got federal aid. So my tree chart's going to branch off like this now because I'm running out of room. So this is federal aid, and the chance that they got federal aid is going to be this small percentage times the percentage here. So of males, 44.8. So we're going to do 0.448 times 0.257. And we get 0.115. So this would be like saying federal aid given male, given aid. So there's like two conditions here that have to be met before we can even get to federal aid. And then, of course, we're going to do the same thing, except for this time we're going to do our 0.257 times 1 minus, and then 0.448, right? The complement of this would be the ones that don't get federal aid. So 0.448. This is 0.142. So that's the chart. Let's go a bit quicker this time. So that means that for this one, it's going to be the same deal. Those that don't get aid, well, they just don't get aid at all. So they're just completely out of luck here. There's no aid for them, so they wouldn't get federal aid. And then we'd say, okay, well, we'll go down to the female now. And we're going to split into two categories. And the ones that get aid, well, how many of the females get aid? 65.2. So we're going to have 0.5758 times 0.652. Right, that's what it said, 652. And we get 0.3754. And then if we do that same thing, 0.5758 times 1 minus 0.652, right? These are the ones that do not get aid. We get out 0.2004 when rounding. We can check this by adding them together. 0.3754 plus 0.2004. And we get 0.5758, which is it's exact in this case. But even if it wasn't, if it was like just barely off, it'd still be fine. Be a rounding problem. And then finally, we have federal aid and not federal aid. So this is going to be 0.3754 times, and then where's the federal aid? 50.4. 50.4. This is 18. Whoops, this should be 0.5. Silly mistake there. This should be 0.504. Because this is a percentage. 48% of males, and this should be a percentage. All right. And that's going to give us 0.1892. And then we're going to do this same thing, but this time with the complement, 0.3754 times 1 minus 0.504, and we get 0.1862. And when we add these together, we should get something very close to this. So we do 0.1892 plus 0.1862. And we see we do get this pretty much out. All right, so now we have our fantastic tree. Holy cow. It takes a while to make, but this is the general strategy that I think a lot of people will use if it's hard to tell just reading a bunch of words and numbers and stuff. All right, so for A, it says male without aid. Now be very careful, the word given is not in here. So we have to consider males and females as our sample size. There's nothing that says we're only considering males. This is just the condition, which is where I see the most confusion usually. So this is the condition. So that means that our sample size, right, that's what goes on the bottom. So I'm going to write down here A. And on the bottom, on the bottom is everyone. So everyone all together is 1, right? 0.4242 plus 0.5758. That's going to give us 1. This is everyone all together. And so because we're using percentages here, this is the same thing as just 1. So all the females and all the males. That's how you can think of it. And then we want without aid. Well, what is without aid? Well, this is like saying, okay, well, now we're looking for males. So here are all the males and the ones that didn't get aid. So this is 0.1671. So 1671, which is of course going to be equal to 0.1671. But I want you to understand how this kind of works. You could alternatively get this answer by taking this number, the males and the females, adding it on the bottom. This would be everyone. And then on the top, you would get, in fact, let's do this. Let's do it. This is, explaining it isn't as straightforward. So we're going to go 8083000. So it's plus 10,970,000. So this is everyone. And then on the top, we're going to have males without aid. Well, the males that got aid were these. 60.6 got aid. So we're going to take all the males. So here's all the males. 8083000. And we're going to multiply by the not getting aid. So that's going to be 1 minus 0.606, right? Because 60.6% got aid. So if we take 1 off of 1 minus this, we're going to be left with ones that didn't get aid. We're going to get a number, 0.16171, which is the exact same thing. So there you can kind of see it. So you could just crunch numbers, but if you have the chart, you could just go straight there, which is kind of why we did the chart. But I'm doing it a couple ways because I really want to explain to you how this kind of works. So, all right, so that's A. Let's do B. Male given aid. All right, so we've got the word given here. Given means we're assuming a condition. So the condition we're assuming is that they've already got aid. That's the condition. It's not that they're male. The male is the probability condition, but I guess it's safer to say assumption. Our assumption is that they have aid. So our sample size is going to be everyone who got aid. So the ones that got aid is this right here, 0.3754, and this 0.257. These are the ones that got aid. So right here, we're going to have 0.3754 plus 0.257. These ones got aid, right? That's our assumption. So that makes this our sample size. These didn't get aid, and these didn't get aid. Only these did. And then we want male given aid. Well, the ones that were male and that they got aid, this was 0.257. 0.257. So when we do this, we're going to get our answer. Now, I'll show you another way to get the exact same thing that might be a little more straightforward, but it looks more like this. So we're going to go on top. We've got our 0.257. This is our condition that they were male and they got aid was the given. So they have to have already fulfilled this in order to even be considered. And then on the bottom, we're only looking at people that had aid in the first place because that's what we were given, that they had aid. So the people that had aid were the males. Well, there was 0.257 of them, plus the females, which there was 0.3754. And we're going to get out 0.4064. All right. Now there's another way to do this, of course. So I guess I'll type it out. It's going to be a bit of typing though. So just be ready. So we want the males that got aid. So that's going to be, right, we have 8083000. That's how many males we have. And the ones that get aid are 0.606, right? 606, 60.6%. And on the bottom, well, we need the females that got aid too. So that's going to be 10,970,000. And then we're going to multiply by the percentage of them that got aid. Well, 65.2%. So that's 0.652. So here's everyone that got aid. So this is the given aid. And then on the top, we want males that got aid. So that's just going to be 8083000 times. And then the ones that were given aid, well, that was 0.606 or 60.6%. 0.606. So these are the males that got aid. Because remember, they have to fulfill the given aid requirement. So it wouldn't matter if you just put males here, they would not fulfill the given aid requirement. And so they would not, you would be breaking it. You'd be including males that didn't get aid, but you're told that they were given aid. So this is like, I think the given is the most confusing part. So we're going to hit enter and we get the exact same thing. So but that's why we don't use just the straight up male number. If we use the straight up male number, the ones that we'd be ignoring are given. This is kind of like a fact that we're already assuming is true. And this makes it so that we only consider people that fulfill this fact. All right, now C. All right, so female or receives federal aid. All right, so we've got an or probability here, but we've got no givens, which means that our sample size is once again everyone. It's all the males and all the females. So that's going to be everyone on the bottom. So that's just one. That's everyone. And then we want female. Well, there's 0.5758 that are female. So we've got 0.5758. These are the ones that are female. Or is a plus, receives federal aid. Now, there are females that also receive federal aid, right? They're like way back here or whatever. Well, we've already included them in the female category. So to count them again would be double counting the females. So we've actually already got all the females, so we don't even need to worry about that. So now we only need to worry about males that get federal aid. Well, here's males given aid, given federal aid. So the only males that get federal aid are 0.115. So 0.115 and whatever that is. So that's going to be 0.5758 plus 0.115. And we get out 0.6908. There is another way to get this number. You may have noticed something. We've included with the females, these in all the branches of female. With males with federal aid, we've included all of these. Right, so male, given aid, given federal aid. So the only two that we didn't include were these. That makes these the complement. So if we take 100%, right, of everyone and then subtract off these two bits, we'll be left with everything that's left. So you could choose to do it this way as well. I think it's a little less intuitive, but it's a way to sort of check our work. So we do 1 minus 0.142 minus 0.1671, and we get out 0.6909. So there's some rounding discrepancies here, but you see it's practically the same number. So this is another way to do it. So I really took my time with this one because every single time by every single student, this question comes up. Everyone gets confused here. And it really tests your knowledge on if you know what it means to say given that. If we have a condition A given B, what this really means when we say given B. What is the significance of that? So this is the way you'll do a problem like this. There's a variety of ways of looking at it. If you have any questions about this, by all means, feel free to comment down below. I know it can be a bit of a struggle sometimes to wrap your head around something like this, especially if it's your first go at something like this. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.